We're talking about trigonometry of right triangles. These are going to be used in navigation, surveying, astronomy, and measuring distances. So this is where we are learning some of the things we can do with a right triangle versus one that is not. And part of that is the trig ratios. So this is where when we are looking at sine theta, we can learn that it is the opposite over the hypotenuse. And it's, this is only with right triangles can you use these. So the sine is going to be the opposite side of theta over the hypotenuse. Cosine will be the adjacent over the hypotenuse. And tangent will be opposite over adjacent. And then the reciprocal identities are going to be the reciprocal of that. So your cosecant is the reciprocal of what you know for the sine. So it's hypotenuse over opposite. And then secant is hypotenuse over the adjacent. And then cotangent is going to be the adjacent over the opposite. And we can remember this with SOHCAHTOA. So sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, and tangent, opposite, adjacent. So that can help you remember that. So the other thing that we can look at is that these two triangles, if we look at them, here we have, if we're looking for the sine, it's going to be opposite over hypotenuse. So it'll be 3 over 5. Bring that in. Turn off the light. Does that make it better? I think it's the lighting overhead. So, so it's 3/5. We can also look at this triangle that's bigger, and it's going to be 30 over 50. Well, that reduces down to 3/5. So these are two right triangles with an angle of theta that are similar and have the same ratios. So the size of the triangle doesn't matter. It's the ratios that will tell you if they are similar angles or not. And then, so let's go do a few, and then we'll come back to special triangles. Let's go do a few examples here. Let me back up. So if I give you a triangle, okay, and we're going to make it a right triangle, and this is our theta, and we are told the hypotenuse is 2, or is 3, and then we have 2 and the square root of 5. So we can use this to find the values. So our sine theta is equal to the opposite over the hypotenuse. So the opposite of theta would be 2 over the hypotenuse will be 3. Our cosine theta is equal to the adjacent over the hypotenuse. So the adjacent is square root of 5 over the hypotenuse, which is 3. And then tangent theta will be equal to the opposite over the adjacent. So it would be equal to the opposite is 2 over the adjacent side is square root of 5. But remember, we don't leave those radicals in the denominator. So we're going to multiply by the square root of 5 over the square root of 5 so that we can rationalize it. So we get 2 square roots of 5 over 5. We've talked about this before. Square root of 5 times square root of 5 will get you the square root of 25, which is 5. And then we can do the reciprocal identities. So for sine theta, that's going to get us cosecant theta. Remember, we talked about each of our values get a co. So when they are pairs. So sine and cosecant, cosine and secant, tangent and cotangent. So cosecant theta is going to be the reciprocal of that. It's also going to be known as the hypotenuse over the opposite. So it'll be 3/2. For secant of theta, this would be the hypotenuse over the adjacent, which would be the square root of 3 over that square root of 5. So again, we got to multiply by that square root of 5 over the square root of 5. And we get 3 square roots of 5 over 5. And then cotangent theta would be the adjacent over the opposite. So we'll get the square root of 5 over 2. Oops, sorry you couldn't see. So that's just how we are using the SOHCAHTOA part to figure out what's going on. All right, let's go do another one. So if we have another triangle, another right triangle, and this is our theta again, and we have 3 square roots of 7 and 4. So again, we're going to find our sine theta. Our sine theta, again, is still opposite of our hypotenuse, so it'll be the square root of 7 over 4. Our cosine theta is still the adjacent over the hypotenuse. And our tangent theta is equal to the opposite over the hypotenuse. Opposite over the adjacent. Sorry about that. So square root of 7 over 3. And then our value that goes with our sine theta is going to be our cosecant theta. And so cosecant theta will be the hypotenuse over the opposite, or the reciprocal of that, either way you want to look at it. But you need to be able to look at things besides just, oh, it's the reciprocal of that one. Making those connections will really help you out. So it's going to be 4 over that square root of 7. Let's rationalize that by multiplying by the square root of 7 over the square root of 7. So 4 square roots of 7 over 7. And then our secant theta is going to be 4 over 3. And our cotangent theta will get us the 3 over the square root of 7, and again we'll multiply by the square root of 7 over the square root of 7. So we get 3 square roots of 7 over 7. Alrighty, so let's go look at some special triangles. So on special triangles, there are certain ones that have ratios that can be calculated easily from the Pythagorean theorem. And they are used quite frequently. So these are the ones that we are looking at. So the first triangle is obtained by drawing a diagonal inside of a square. And the Pythagorean identity says that the diagonal would be the square root of 2, because it's a squared plus b squared equals c squared. So you would get 1 plus 1 equal to 2, and then you need to find the square root of that, so it'd be the square root of 2. This is a special triangle that's 45, 45, and 90. The second one is from an equilateral triangle where they're all equal sides, and we end up with a 30, 60, 90 triangle. And so that's another special one that occurs quite often. And you can actually draw a perpendicular line that bisects the base. And we use, again, the Pythagorean theorem to figure out what the sides are. So one of the things I want you to also understand is about your calculator. So with your calculator mode, when you're looking at the input, you need to input it the way that you need it to be. So if you're looking for an approximate answer, an exact answer, and what your mode is. If you're putting in a degree, so the sine of 30 degrees, you need to be in degree mode. If you're putting in a radian, like pi over 3, it needs to be in radian mode. So whatever your input is into your problem, you need to use that input on the calculator. So if I'm looking at, let's turn on my calculator here. So my mode key right there gets me to degree radians. Those are the two you're switching for. So if I want to put in sine of 30, I have to put in it in degree mode versus radians. Because, let's clear this out, if I take the sine of 30 degrees, that's not the same answer that I should be getting because I'm in radian modes. And I can see that I'm in radian right up here on my calculator. So I have to go to mode, switch over to degree, hit enter. Now if I do my sine of 30, I get the 1/2, or with my calculator, if I do the double arrow button, it'll take me to the decimal answer. So that's the difference. Also happens when you're doing sine of pi divided by 3. I'm getting this answer because I'm in degree mode. So I need to switch over to radians, and then I can do my sine of pi divided by 3. And now this is the exact answer because that's what my calculator is set to do. And if I want the decimal, I click the double arrow key and it'll give me the decimal approximation. So the mode you want is the mode you're inputting. So make sure you're in the right mode or you're going to get very, very frustrated with what's going on with your answers because they're not going to match right there. I also have in here a chart for you, the values of the trig ratios for special angles so that you could use those for quick reference. You don't need to memorize anything. Remember, these are going to be the similar answers that we've already seen in our unit circle. All of these values are coming right off of our unit circle. So I did tell you, you need to know this. If you can know quadrant 1, you can figure out the rest. Because then it's just about the signs changing. As in the positive and negative signs. Alrighty, so let's go look at some degrees and figure out what some of these are. So if we're looking for the tangent of 40 degrees, then I need to make sure I'm in my degree mode. And then I can do tangent of 40 degrees. And I should get, we're going to go to 3 decimal places, 0.839. All right, let's do the cotangent of 14 degrees. Well, we don't have a cotangent button, so remember that's going to be 1 over the tangent of 14 degrees. So 1 divided by the tangent of 14, and that gets us 4.011. All right, let's look at cosine of 20 degrees. So the cosine of 20 gets us 0.9396, will get us 0.940. And then we'll do the cosecant. Oh, yes. So cosecant of 80 degrees. Well, we don't have a cosecant button, but cosecant is the reciprocal identity of sine. So we can do our 1 divided by the sine of 80. So 1 divided by the sine of 80 degrees. And we'll hit our enter button. We get 1.015. So 1.015. So that's where you need to know and be able to see those reciprocal identities in order to figure some stuff out. All right, so we are going to realize that a triangle has 6 parts. So let's go look at a triangle right here, just so we have a reference. They have 6 parts. They have 3 sides, and they have 3 angles. So we're going to find all the parts off of a triangle. So I'm going to draw us a triangle, and we are going to find all of the parts of the triangle that we need to find. All right, so again, it has to be a right triangle to do the things we're doing. So this will be angle A, B, and C. And our little a will be across from angle A. Our little b is across from our big B, and our little c is across from our big C. We are given that this is 30 degrees and that this is 12. So that's what we're only given 2 parts. So, well, and we're given a third one actually because of the 90-degree angle. So the first thing we need to do is figure out what we can know. The easiest part is to know that we can figure out angle B. We need to understand that all of our angles inside of our triangle equal to 180 degrees. So we can take 180 and we can subtract out the 30 plus the 90, and that'll get us a 60 degrees. So we now know that angle B is 60. Now, let's go find little a. So to find little a, we know the angle and we know the hypotenuse, because the hypotenuse is always across from your right angle. So we need to use one of our trig functions to find that. So we're going to use sine, because sine would be opposite over the hypotenuse. So I can do, let's switch colors here. The sine of 30 degrees is equal to our opposite, which is A, over the hypotenuse, which is 12. Now, if I multiply both sides by 12, I end up with 12 times the sine of 30 degrees is equal to A. Well, I can put this in my calculator, but I can also understand from my unit circle, which is what I want you to really make some connections with. So the sine, remember, is the y value of 30 degrees is going to get you 1/2. If you know these values, it's going to make your trig a little bit easier than just always putting it in the calculator. So with the sine of 30, I know it's 1/2 is still equal to my A. So this means that 6 will be equal to A. So I found my A. Now let's go find B. So for B, I can do the cosine. The cosine of 30 will be B over the 12. So our cosine of 30 degrees will be equal to B over 12. And then we're going to do the same thing. We're going to multiply by 12 and end up with 12 times the cosine of 30 degrees is equal to B. And then if we know from our unit circle that the cosine of 30 is equal to the square root of 3 over 2, then the 2 goes into 12 6 times. We end up with 6 square roots of 3 is equal to our B. So we have found the pieces that we were missing. We have our angle, we were given 3 parts, and we found 3 parts. All right, let's go do another one. But we're going to do it a little bit different. We are going to look at a word problem here. And with that, we're going to talk about the angle of elevation. And the angle of elevation starts at the standard position. Remember, the standard position is that x-axis. And it goes up like an elevator and starts from the ground. So the angle of elevation goes up, the angle of depression goes down. So when we're talking about the angle of elevation, it's starting here and moving its way upward. And they can use that to measure the heights of buildings and mountains and all kinds of things. We are going to find the height of a tree. So if you've ever been going down the road and you're up in the mountains and you're like, they know the height of the mountain. Well, how do you measure a mountain? They don't have a big enough measuring tape. They're using trig to do this. So we've got a giant redwood tree that casts a shadow 532 feet long. We want to find the height of the tree if the angle of elevation of the sun is 25.7. All right, so we're going to draw a tree. And I am not an artist, I am a mathematician, so but we've got a tree and it's casting a shadow. And we're looking for the angle of elevation. And that shadow is coming from our sun up here. So the sun is casting the shadow of the tree. And we were told a couple of things. We were told that the shadow is 532 feet long. And that the angle of elevation of the sun, this is the angle of elevation of the sun. So the sun is rising up there. So usually I have students that put the angle in the wrong spot. So this angle is 25.7. And what we want to know is how tall is the tree? Well, our height is on this part right here. This is the height of the tree. So we have to look at what we know and what we're trying to find. So we have our angle, and next to our angle, because this, we're assuming that the tree grew straight up, so we can use our right triangles. So if we're looking at this one, this angle, it's the adjacent side, and we need to find the opposite. So you can do this a couple of ways, but if we're looking at learning the opposite with the adjacent, going back to our trig ratios, we can use tangent. Remember, tangent theta is the opposite over the adjacent. Well, that'll make it way easier than if we try and do sine or cosine on this. So I can find the tangent of 25.7 degrees would be equal to the height, which is our h, divided by 532. So now I can multiply both sides by the 532. So that gets us 532 times the tangent of 25.7 degrees would be equal to our h. Now this one is not one of our standard ones in our unit circle. So we're going to have to pull out our calculator, and we are putting in a degree, so we need to be into degree mode, which I can look right there and see its degrees. So 532 times the tangent of 25.7, and we end up with our height is equal to 256 feet. So we're able to figure out the height of the tree using our trig ratios.